Okay, I'm back, and now what I'm going to do is to give you the data that you're going to put into your third chart. So the chart that is right above where it says post lab questions. And for star number 1, you are going to put in 1.2. For star number 2, 1.1. For star number 3, 1.3. For star number 4, 1.5. And for star number 5, 2.5. So now you should have enough information in order to be able to fill out the rest of the chart. So let's go to the second column that you're going to fill in. So the second column is the total angle through which that star went through. So the star went back and forth a certain number of boxes, a certain number of divisions. And what we need to do is to convert the number of boxes into an angle. Well, all right, now let's go back up in the lab to the second chart that you filled in. And you know what the angular width of one division was. That was the very last number that you filled in on that chart. Okay, so all you got to do is to take that number, which turned out to be what again? Let me look at my data. It was 0.5003. Take that number and multiply it by every number in column number 1. So for for the first one, it was 1.2 divisions. So if you multiply that by 0.5003, then you get the first number in the next column should be 0.60036. Okay, now you do that for the rest of those numbers in the column titled total angle in arc seconds. Alright, so now we're ready for the next column, which is entitled the parallax angle in arc seconds. Okay, now in order to visualize what's going on here, if you would go up in the lab until you get to the picture, it's figure 15.2. So go up into the pre-lab where it says figure 15.2, and it has a picture of a star, and then it has a picture of the Earth's position in January and then July, and it has a picture of the sun. Okay, what you have just been measuring has been the total parallax shift. The angle that is being, you're seeing the angle as the Earth goes from January to July. But that's not the parallax angle that goes into the parallax formula. That angle is theta. So do you see it in the picture there? So look where it says the parallax shift is 2 theta, but the parallax angle, the one that we want, is just plain old theta. So what do you think that we need to do with all of these angles that we have just calculated? we need to take them and divide by 2. So then that would be the parallax angle. So go back down into your chart, and then in the next column where it says the parallax angle, take all of your angles from the total angle column and divide it by 2, and then fill in that column of data. Okay, now we're ready to do the next column and calculate the distance to each of these stars in parsecs. And in order to do that, we're going to use the parallax formula. So what's the parallax formula? R equals 1 divided by the angle. So we're going to take each of the angles that we've just calculated and flip them. So 1 divided by each of those numbers, and then put that in that column labeled distance in parsecs. I bet you want the answers. Alright, here's what you should be getting. So for star number 1, you should be getting 3.331335. For star number 2, 3.634183. For star number 3, 3.075078. For star number 4, 2.665068. And for star number 5, 1.599041. Now we're not going to use all of those significant figures. I'm just telling you that's the raw data that I got. Alright, now we're ready to go to the last column that says what would be the distance in light years. So we now know the distance to these stars in parsecs, and now we want to know what's the distance to these stars in light years. So 1 parsec is 2.26 light years. So therefore, if you had a distance in parsecs of, let's say, 1.5, how would you convert it to light years? Multiply it by 2.26. Okay, so you're going to take every number in that second to the last column, and you're going to multiply it by 2.26 and then put it in the last column. Okay, and I won't tell you what you come up with. I'll let you do that. Okay, now we are ready to see how close we got to the correct answers. So you're going to go back to, oh, you can't do that, can you? Sorry about that. Well, I did it, and I got out of the 15 of the boxes that they wanted me to enter, I got it right on 12 of them. So I was very pleased with the experiment. So the answers that you have just generated are correct to within 2 significant figures. So here's what I want you to do now is you're going to go to the post-lab questions, and you're going to answer all of those questions. Okay, let's go down to post-lab question number 6. What happens to the parallax angle as the distance to a star gets larger? Now you can do it by just using the formula for parallax. R equals 1 divided by the angle. So you should be able to figure that out just by looking at the formula, but you can also figure out the answer to it by looking at your data. Look at how the distance to the star changes and then look at how the angle changes. And then on question number 7, give 2 reasons why the parallax method cannot be used to determine the distance from Earth to stars further than a few hundred light years. So as the distance to these stars gets larger, you should notice that it gets harder and harder in order to use this method. So one reason you should see immediately when you were working it on the computer has something to do with the angle. Okay? And then there's another reason. So think about a light bulb and what happens to that light bulb the further away it gets from you. So that ought to be your second reason in answering question number 7. Okay, so we're finished with this lab, and you need to do both the pre-lab, the lab, and the post-lab, and then email it to me. So I will continue making videos for the other labs that we have done in lab in case you missed lab. All right. So until next time, goodbye.